Hi girls! The lesson for today is going to be the unit circle. A few things I want to mention about the unit circle. First of all, a unit circle is just a circle that has a radius of 1 unit. So although we're going to be looking at the unit circle in a very large scale, if you were to look on a typical sheet of graph paper, it'd be a very tiny circle with just a radius of 1. Now keep in mind throughout this lesson, a radius is a segment that goes from the center to the outside edge of the circle. So anywhere that you draw a radius on a unit circle, it's going to have a value or a length of 1. And we're going to be looking at this radius of 1 all around the unit circle. Okay, this is going to help you find trig ratios for special angle measures without the use of a calculator. Typically, we do this lesson and we ask you to memorize all of the values that we're going to be finding in this lesson. For this lesson, it's just going to be an overview of it. It's going to be your first look at a topic that you're going to study more in depth when you get to college algebra, trig, pre-calc, or calculus. So this is just your first look at it. You'll be able to use your unit circle on all of the activities I ask you to do, kind of as a cheat sheet, but just know your goal in your high school career or college career is to know this unit circle without looking at a filled in version, which we'll do at the bottom of this lesson. Okay, so first off, what we need to do is we need to find the special angles of the unit circle. So keep in mind, you've already done a little bit of work with angles. You know that there are two types of angle measurements. You can measure angles in degrees, and you can also measure angles in radians. Now, degrees are something that we're a little bit more comfortable with because we've used it more in our past, and so we'll start with the degrees. So whenever we talk about a unit circle, we always talk about this as being the standard position. We're going to rotate a ray around a circle, and we're going to talk about as this ray rotates, how many degrees is the angle that we create. So we call this standard position, this initial position, 0 degrees. If I were to rotate this all the way up here to the top, you can see that this is a 90-degree angle, and you're very comfortable, I know, with a 90-degree angle. So this angle up here we'll refer to as 90 degrees. If I keep rotating 90 degrees all the way around the circle, I'll end up over here at this point. This point is a rotation of 180 degrees, or half of a circle. Down here we have a rotation of 270 degrees. And then if I rotate an angle all the way around a circle, we all know that that could be 360 degrees. So this position refers to 360, or if you go all the way around like this, I'm sorry, 0, and if you go all the way around, it refers to 360 degrees. Okay, now if we cut this circle into eighths, what we're essentially doing is we're cutting all of these 90-degree angles that we made in half. And of course, half of a 90-degree angle is 45 degrees. So I'm going to cut my unit circle into eighths, creating little sectors or little pieces of pizza, as I like to refer to them, which have a rotation of 45. So 0 is here, 45 is here. If I add 45 degrees more on, I get to 90. If I add 45 more degrees of rotation, I would be over here at 135 degrees, right? Because what I'm doing is I'm doing 90 plus 45, and that's 135. Rotate 45 more, and you'll see you're at 180 degrees. So all I'm doing is adding 45 degrees all the way around the circle. If I'm here at 180 and I add 45, that's going to be a rotation of 225 degrees. So again, what we're talking about is if I had a ray right here, I started here and I rotated that ray all the way to here, that would be a rotation of 225 degrees. All right, if you keep continuing this, you add 225 to 45, you'll get 270. And if you add 45 to 270, you get 315 degrees. So those are what we call the special angles of a unit circle that are divisible by 45 degrees. basically cutting the unit circle 360 degrees into 8 sections. Okay, now you've also already learned that if you have degrees, you can turn degrees into radians using the conversion factor that pi is equal to 180 degrees, right? That's our conversion factor. So if I want to talk in radians, I could say that this is 0 radians, and then halfway around the circle over here at 180 degrees, that is pi radians. 180 degrees equals pi, that's why it's your conversion factor. Okay, now if halfway around the circle is pi, then that must mean all the way around the circle is 2 pi. And you've talked a lot about this in your previous lesson about the idea of a radian being a radius on the outside of a circle. And if you marked off radians all the way around the circle, it would take you 2 pi of them, basically 3.14 and 3.14 is 6.28. It would take you 6.28 radii to get all the way around the circle. That's a previous lesson on radians, though. Okay, so here we're at 0 and 2 pi. Now, if just halfway around the circle is pi, and I want to cut that in half up here at 90 degrees, this would be pi over 2 radians. Now keep in mind, anytime that you're confused on how many radians it is, if you know the degree measure, you can always just do the conversion, right? 90 degrees, you multiply that by pi over 180, which is your conversion factor, and you can see what you get here. You get pi over 2. So 90 degrees is pi over 2 radians. Okay, so if this is 1 pi over 2, this is 2 pi over 2, which is pi. This must be 1.5 pi, or 3 pi over 2. 270 degrees is 3 pi over 2 radians. Okay, now let's think about this circle as cut into eighths, right? Half of a circle is pi. So if I just look at this top portion, right, this is considered pi. This must be a fourth of pi, okay? An eighth of 2 pi or a fourth of 1 pi, okay? So each of these will be 1/4 of pi as I work around the circle. So this is 1/4. Up here at 90, this is 2/4. 2/4 is the same thing as pi over 2, so I don't need to write that down. So this is 2/4. This one must be 3/4 pi, which makes sense if you understand fractions, right? This is 3/4 of pi. It's a little bit confusing because pi is only half of a circle, so this is 3/4 of half of a circle, right? Keep going and you get 4/4. 4 over 4 is just 1 or 1 pi. 5/4. 6/4 is 3 pi over 2. 7/4. And then finally 8/4, right? And as I've been doing kind of verbally, 8/4 is the same thing as 2 pi. So you can always look at this circle if it's divided into eighths as each section being a fourth of pi. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay,